It's just a fun little thing. It's based on history. Okay, it is a historical fact what actually took. Yes, Carla, it is uploaded there. It's just a fun little thing.
So please can you just unmute yourself so we can hear the video?
Sorry, what's the matter?
Can you unmute yourself so that we can hear the video because we can't hear any sound with the video, or is it like no sound?
Oh, is there no sound coming through of the video?
No, sir. No.
So I think because you muted yourself, no sound was coming through.
Okay, you know what's actually happening is, yeah, I'm using a headset and the microphone is right next to my mouth. So, and the headset has also got an earpiece to it, so it's going into my ear, but not through my mic. So what I'll do is I will unplug my heads. How am I going to do this? Okay, I'm going to try and put my earpiece next to the microphone, and hopefully you'll hear sound from there.
So are you sure you didn't just mute the presentation account?
Sorry, what was that, Fifi?
So didn't you just
So
mute the
it said that-
presentation account, sir?
Yeah, the presentation account is muted, so it says you can't unmute someone else's presentation, but it's showing that your presentation is muted.
Oh, okay. Okay, I'm just gonna have to. It doesn't seem to, I can't seem to unmute it myself. Okay, so let's just try this again, and let's see if you can actually hear it now. Is that better? Were you able to hear that?
I can't hear anything.
Still not being able to hear anything, eh?
No, sir.
Okay.
So can't we just watch it ourselves on our devices?
Okay, is the sound still not coming through?
No, sir.
Okay.
Because you uploaded it on Google Classroom, we can just go watch it quickly.
Yeah, I have uploaded it on Google Classroom. Okay, so yeah, you guys can just watch it. It's really, it's just a fun little thing just to enjoy the introduction to series. Okay, so we seem to have quite a few on here now. Sorry that I missed you guys coming on. Okay. Okay, so I'm now going to just show you a brief little introduction via PowerPoint. Okay. In terms of series, now remember we've been talking about sequences, and sequences have been a list of terms that all follow a particular pattern, and we've had a look at two particular patterns in the arithmetic series sequence and geometric. Now, in terms of series, the series is simply just if the sequence is listing of the terms, then the sum of those terms. So if we take each term and add it together, that is called a series. So sequence, just the listing of terms. Series is the sum, adding up of those terms. Okay. So basically a series is the expression formed by adding the terms in a sequence. Okay, we've spoken about Carl Friedrich Gauss, and the challenge that he was given in the 18th century is how quickly can the natural numbers from 1 to 100 be added. Okay, so he was in primary school when he did this. I don't know about the truth of the teacher needing a break, okay, but remember they had no calculators, so they had to, as a primary school class, they needed to actually sit down and add up all those numbers. Now, if the teacher was wanting a break, that kind of actually failed on him miserably, because in less than 1 minute, young Carl presented his answer. Okay, and it was right. So sequences can either be a finite set of terms, okay? So there are only a certain number of terms in the series, okay? Or infinite. They can continue indefinitely, right? So the pattern, the set of natural numbers is an infinite sequence, okay? Because it just carries on going to infinity. If we're going to add these terms, if we're talking about an infinite series, we're not going to ever be able to add all the terms in a series. Having said that, watch this space when we come to adding an infinite series next week. Okay. But a partial sum is when we add certain terms. Okay, so the first n terms of the series is what we call a partial sum, but you don't need to worry too much about that. Okay, so the sum of n terms is denoted by Sn, just like the term is Tn, the sum is Sn. You would have been exposed to this yesterday in that question, that last question of the exercise. Okay, and you do need to make sure that you're very aware of what is being asked in a question. Be careful to find SN if they're asking you for sum, or TN if they're asking you for a term. Okay. And so SN is basically just then the addition of term 1 plus term 2 plus term 3 all the way through to TN, the nth term, basically. Right. So that's it in terms of what a series is. Okay. We're going to have a look in more detail at arithmetic series and geometric series next, starting tomorrow. Okay. But for today, then, there is that investigation on series, or introduction to series, as a worksheet that I put on the classroom. And yeah, I want you guys to work on that right now. It's kind of based on that video as well, to a lesser degree. So if you didn't really get the gist of what was going on in the video, then you can watch it again. I have uploaded that onto the classroom as well. All right, guys, just before you go off and do that, I see most of us are here now. We're missing 2. I presume 6 is one of them. And I'm not too sure who the other person is right now. It might well be Lutfia. But on the classroom, I see some of you did go to the wrong link today, and my apologies for the confusion there. But on the classroom, I'm not going to be posting daily links anymore, because on the classroom itself, and I'm going to just present my window to be able to show you. So on the classroom itself, we would have gone to this one here. Okay, I'm no longer going to do that, because our classroom itself has a permanent Google Meet code. So you can just go onto the classroom and you can click onto that one, and then you can join in to this meeting. Okay, so I'm no longer going to be posting links. You will just continue to use that link that is on the classroom. Okay. Guys, any questions? Kelly, I'm glad you could join us, and a couple of others that have come in. Okay. Next, I see your question and I understand what you're getting at, and perhaps I can add it onto the PowerPoint. So I'll add it on as we go. So I'm just going to share my screen again. Okay, so for example, we could have a sequence that has 1, 7, 13, 19, 25, etc. So that would be the sequence. If you are now going to convert this into a series, okay, the series is simply the exact same sequence, but instead of a list, it's the addition of the terms. Okay. So that there, because I've got the little dots at the end, that means it's an infinite sequence or infinite series. Okay, now I could ask you to find the sum to calculate S6. Now what S6 means is that we're looking to find the sum of the first 6 terms. Okay, so we've got 5 terms listed there, which means we need to have a look at the pattern and then work out that we have a common difference of 6 with each term. So if we have a look at that, then we can then add those terms together And we should get an answer there of 96, I think. No, bigger than that maybe. No, should be 96. Yeah, 96 is the final answer there. So even though our series is infinite, we can limit the number of terms that's being asked for by saying S6. Okay, this over here, this series over here would actually be denoted by come on. Sn. Yeah, because we're going to n terms, we don't know how many we're adding there. Right, does that make it a bit clearer, guys?
So, but what happens if like they ask you for S100 and you don't have the pattern until that number?
Okay, Carla, you don't need to worry about that for today. Okay. What you're doing today is you're actually going to be doing a bit of an investigation where you're going to be developing a formula that you will then use. Okay. So, Fazani, I think I've just answered your question as well. And hopefully Nicola answered your question. In that the series that you're going to be looking at is both is going to be arithmetic to start with, but we are going to investigate both. We're going to have a look at the sum of arithmetic and geometric. Okay, so the investigation you're going to be doing is going to be small enough, hopefully, for you guys to be able to develop a formula on your own. Obviously, I will again later this evening post the working out and the solution to that investigation. And then tomorrow, we're going to look more specifically at formulae that relate to arithmetic series. And then next week, we'll pick up on geometric series. And then, so you will get formulae. So if they ask you to find S100, you'll be able to use your formula to be able to find S100. Van, I've posted those solutions on the classroom. They are there. 6, so glad to see that you could join us today. Guys, any other questions? Anything you're unsure about? I think go into the, is this formula the one by Gauss, sir? Yes, it is 6. But hopefully that's what you're going to develop as you go through it. So this is the, let me just share my screen again. So what I'm about to show you is the document that you're going to work through. Okay, so there's the first question there is given the general term, determine the first 7, calculate S7, write down the first 3 terms, the first last terms, and then use Gauss's method to work out S100. Okay, so go back to the video. If you have a look at the video, what Gauss did was he simply just turned the series around, added each term, noticed that the terms gave the same answer, and then worked from there. Okay, so have a look. If you do need to have a look at that again, it has been, that's also on the classroom. And then question 2 is also, and question 3 are all about different types of questions. Okay. And eventually we actually build up to something a little bit more general in question 3. Okay. Guys, this is challenging. Okay. Gauss was, as you suspected an extremely bright man, and so not that none of you have that ability, but certainly it's not going to be something. It's a different way of thinking, and I'll just encourage you to give it your best shot. Okay, don't panic about it. Please don't panic about it. It's not for marks. Okay, it's hopefully just there to actually give you a better understanding of the formula that we are going to be using from tomorrow. Any other questions, guys? Great. As with yesterday, I'm going to stay on the line again, and you can busy yourself with that work. And if you have any questions, you can just rejoin the meeting, and I will answer them to the best of my ability.
So, where did you say the questions were exactly?
The questions are on the classroom 6.
In classwork. I'm looking at the sequences and series over here, and which one is it under? Series introduction.
So it'll be the series introduction.
Okay, thank you.
Okay, so it's under the series introduction. It was posted at 7:30 this morning.